Okay, today we're going to be looking at running a Pearson correlation in SPSS. And the good news is it's a very easy, very straightforward calculation to perform in SPSS. You've already done more sophisticated versions of correlation analysis with the factor analysis and the reliability testing with Chromebox Alpha. All uses this more simplified Pearson correlation as its base. And a correlation analysis is something that's appropriate to run when you are looking at two continuous level variables. So if you're looking at categorical variables, something like the t-test or the ANOVA might be more appropriate for you. But today, let's say we are interested in looking at the relationship between age and highest education level attained. And what we can do is pop up to Analyze, and we're going to go down to Correlate, and we're going to select Bivariate. And I already have my two variables of interest over here. So what you're going to want to do is just drag them over. And if we just look at our options here, we are going to stick with Pearson correlation. There's other ones that exist, but we're not going to be looking at those today. As far as test of significance, SPSS is going to tell us whether our Pearson correlation is at a significant level or not, and we want to stick with the two-tailed for our purposes here, and that's for the same reasons that we would want to do two-tailed for our other tests that we've performed earlier in the course. And if we select flag significant correlations, what that is going to do is give us a little asterisk next to all of our correlations that are significant. And if we just go up to options, we're going to select means and standard deviations, and then we're off to the races. All right, so if we take a quick peek at our means here, we can see that people on average are 41 years old, although they can be quite a bit older or younger with a standard deviation of 16. And our highest education level attained is 4, and that's somewhere in secondary school. So that's somewhere in high school is going to be our average there. And one important thing that I'm going to note about correlations before we actually look at our correlation table is that a correlation is going to be represented by a number ranging from -1 to +1. So you're never going to have a correlation outside of that spectrum. And a 1, as you can see right here, is going to represent a complete positive correlation, which means that all of the variance in one variable is accounted 100% for the variance in the other variable. And this makes a lot of sense if we're just taking a peek here, because when we're looking at this correlation, we're looking at highest education level attained compared to highest education level attained. So that's a complete correlation because we're literally looking at the same thing. A 0 would represent two variables that have no bearing on each other whatsoever. So that would be something like highest education level attained and the day of the month that you were born in. We wouldn't expect to see any correlation. One variable has no bearing on the other variable whatsoever. And a -1 would represent a complete and total correlation, but a negative correlation, so in the opposite direction. So as one variable goes up, the other variable goes down. And I'm trying to think of a good example off the top of my head that would be almost a complete correlation. And I can't think of one off the top of my head, but maybe I'll come back to you if I do think of one. So looking at the variables that we have here, we're looking at education level and age, and we can see the number of interest here is the negative 0.207, and we can also see 2 asterisk signs. So that's going to tell us right off the bat that our correlation is significant at the 0.01 level. And so we can see that both in the significance column and down here in the bottom row as well. And we're also going to pay attention to this negative sign. So this means that these variables run opposite to each other. So as one goes up, the other one goes down. So what this is representing for us specifically is that younger people are more likely to have a higher education level. And when I was first looking at this, I actually kind of expected the opposite. It made sense to me that the older you get, the more time you have had to have completed school. But if we're looking at and perhaps that would be the case if our average age was something like 25 or 20, then that might make a lot of sense. People literally had more time. But if we have an average age of 41, well then, and a standard deviation of 16, that's a lot of people in their 50s and 60s who went to school at a time when it was just a lot less likely to go to college. So after thinking about it a little bit more, it actually makes more sense. And we're also going to pay attention to, so we paid attention to the significance here with the asterisks, the negative sign, which tells us that they run in opposite directions. But let's look at the number itself. So it's 0.207. And if I pull up this handy dandy effect size table, and by the way, these correlation coefficients can be thought of as an effect size. In fact, they are an effect size. It is a degree of, they account for how much variation in one, how much it accounts for in the other. It is a magnitude that we're looking at. So at any rate, if we're looking at a 0.1, that's going to represent sort of a small relationship. A medium would be a 0.3, and that's going to, a 0.3 is going to represent a medium, and a 0.5 is going to represent a large. And of course, anything higher than that is going to represent a very large. And if you're looking at a 1 or a negative 1, if you're looking at a 1, it's going to represent, you're basically looking at the same variable. And if you look at this percent of variance over here, we're going to explore this a lot more when we look at regressions. But this is the percent that one variable accounts for the other. And a quick heads up is that if you just square any of these values, you're going to get what's over here. So 0.5 is going to give us 0.25 or 25%. 0.3 is going to squared is going to give us 0.09 or 9%. Same for 0.1. It's going to give us 0.01 or 1%. All right, so back to our table here. We got a 0.2, so that's going to represent somewhere between a small and a medium relationship between those two variables. And next, I just want to show you that we can plug in as many variables as we want, and it's just going to give us a bigger and bigger correlation table. So it's only going to look at one compared to one other one, but we can do that as many times as we want. And for our sake, we're just going to throw in a third variable, and we're going to look at how many children do you have? So we're going to plop that in there. And now we can see we have a slightly bigger table, and we have a lot of significance again. First let's look at the average. People have on average just under 2 children. And of course, we're going to see ones diagonally here, and we're going to see that we have an even stronger relationship between highest education level attained and how many children people have. That is to say, the more children one has, the less likely they are to go to college. For age, we have a positive relationship between how many children you have and how old you are. That makes a lot of sense. You don't get children removed from you. Once you have a child, you have it, and the older you get, the more opportunity you have to have more children. And we have the same correlation between how many children we have, our age and highest education level attained is still the same. That's not going to change. And I want to give you guys just a quick peek at what an APA style table would look like for a correlation. And we'll just pop over here. So it's going to look quite a lot like our output that we have here with some notable differences. Let's actually look at this one. This was for my project last year, and I was looking at bully victimization and school enrollment size and school level and school urbanicity. And we can see here, these represents this diagonal kind of, well, it's not a row or a column, just this diagonal here represents where all of these ones would be here, because we're looking at ourselves. We have bully victimization represented by a 1 in the column, a 2 enrollment size represented over here, school level represented by the 3 over here, school urbanicity represented by the 4 over here. And you can also see that we don't have any numbers that's on the right side of this diagonal, because they just are the same values over here. They would just be mirrored over here. And I chose to include the means and standard deviations of 2 of the variables in this correlational table. You don't always see that, but I do have it here. I have this named in italics up here, just telling me what the table is, and we have all sorts of notes down here.